So today we are going to do rational and irrational numbers. We are going to just classify them and talk about how to determine how a rational number is or an irrational number, and then also talk about how to convert those fractions into decimals. Now, this is just a quick review over what you guys have done before. Please keep in mind that with a lot of this, you are allowed to use your calculators, but in the case that you don't, this is a good example, okay? Now, to begin off with real numbers, when we're looking at real numbers, we're looking at the set of rational numbers and the set of irrational numbers together. So basically, if I look at this little chart that I have right here, all of the rational and irrational numbers are going to be considered real numbers because the box that I have right here, let me get my pointer. The box that I have right here, all this blue box is real numbers, so we're really just talking about any number. Now, for rational numbers, when we look at rational numbers, that can be written as the quotient of two integers. So we can look at those whole numbers, we can look at positive and negative whole numbers, we can also look at those fractions. Now, when we're looking at those fractions, though, we want to make sure that we're looking at fractions with two integers. What I mean by two integers are two whole numbers at the top or the bottom. And then for decimal form, you want to make sure that you're looking at decimals that either terminate or repeat. So by terminate, I mean they come to an ending. So if I think about like 1.5, 1.5 does come to an ending because 5 is that last decimal placement. And then compared to the ones that repeat, I'm looking to see if there's any type of pattern. So, do I have anything that goes, for example, 4, 5, 4, 5, 4, 5, continuing? Yes, it continues, but there is a pattern repeating as well. If you see something that says like 0.33333 all to the end, that is considered a rational number because it is repeating or it terminates. Okay. Now, an irrational number. When we look at those irrational numbers, we're looking at numbers that can't be written as a quotient of two integers. So once again, the quotient of two integers is when I have two whole numbers at the top and the bottom, or get like a whole number because the square root of 49 is 7. We're thinking about all the opposite on irrational. So, for example, if I think about decimals, my decimal does not finish here. It doesn't just go 1.24. It just keeps going on forever. And these dots right here mean that it will continue on forever. There's also not a pattern here. So, once again, it's not terminating. There's no repetition here. And other numbers like pi is a decimal that never finishes. The square root of 2, I cannot get a whole number out of that. So what I'm thinking about is like, is there a number that can multiply to itself to get to that 2? And there isn't. Okay. So let's talk about classifying rational numbers. So when we look at this, if you guys want to pause this for a little bit and try to um, classify each of these numbers, I would go ahead and try and classify them. Now, 5, pausing now, if you want to pause, okay? So looking at the number 5, 5 is a just natural number. It is a positive, it's a whole number, so that is considered a rational number. The next one over is considered an integer. Although, yes, it does have a negative, it is considered a rational number just because it does not have any type of non-terminating decimal or no repetition. It's just a whole number with a negative. Okay. Pi is going to be considered irrational. Remember, irrational means that if I look at decimals, it goes on forever with no type of pattern, and pi does not have a type of pattern here. Next one is the square root of 5 over 3. Now, if we're looking at fractions to determine if it's a rational number, it's an integer at the top and the bottom, which is the numerator and denominator. Now, if I do the square root of 5, the square root of 5 will not give me a whole number, which is that integer. Therefore, this is irrational because I can't get a whole number out of that square root of 5. Okay. 3 over 8 is the next one. That is considered a rational number because once again, I have an integer at the top and the bottom. Then I have the square root of 25. The square root of 25 is actually rational. If I think about the square root of 25, I'm thinking about one number I can multiply to itself to get to that 25. 5 times 5 does give me that 25, so therefore I can get an integer out of that square root. -4 is also going to be rational. Once again, it's just a integer with a negative on it, so no misconception there. Number 7 is going to be rational as well. Whole number, natural number, considered rational. and square root of 8. So the square root of 8 is actually going to be irrational. I cannot get one singular number that I can multiply to itself to get to the 8. Um, so the square root of 8 is irrational. And same thing for the square root of 15 over 5. The square root of 15 does not have a specific number I can multiply to itself to get to the 15. Therefore, it is irrational. Okay. All right. Now moving on to the next portion. So here we have opposite numbers and absolute values. What we're really looking for here is, do we know what the opposite of a specific number is? An absolute value. We need to make sure we're looking at those brackets to make sure that we know what a absolute value is, okay? So looking at opposite is a number that is the same distance from 0, but on the other side of 0 on a number line. So we're really looking at the opposite of wherever, whatever number is given to me. So if I have a positive 4, the distance from 4 and 0 is 4, but if I go the opposite way, it is going to be -4, because if I go from 0, go 4, opposite, -4, okay? So looking at these examples right here, first I have example A, -4. Once again, I'm thinking of opposite, so the opposite of a negative is going to be a positive, so my answer here is just a +4. Same thing goes for number 6, letter B, letter B, number 6, okay? For 6, it is a positive. The opposite of a +6 is going to be a -6. For letter C, I have a +15. The opposite of a +15 is -15. And letter D, when I think of the opposite of a negative number, it's once again a positive. I do have a -9 here, so the opposite is a +9. Okay. All right, now looking at the absolute value here. The absolute value here is the distance a number is from 0. Now, it does have about the same definition that a opposite number would have, but notice how it says the distance is positive. With an absolute value, whatever's inside the bracket is going to make that number specifically positive. Whatever is outside of the bracket, that stays exactly as it is. So for example, the first example I have letter A. Remember, absolute value makes it positive. If it's already positive, it stays as a positive because I'm just making everything positive. So letter A says the absolute value of 5. The 5 is a positive inside the bracket, so it just stays as a +5. For letter B, I do have a -3 inside those brackets, so the absolute value of a -3, because it is a negative and those brackets make everything into a positive, I now have a +3. For letter C, remember, we are looking inside the brackets. If I look at these absolute value brackets, inside I have an 11. So yes, that 11 will stay exactly the same. But outside of the bracket, I have a negative. Because that is not inside of my brackets, I will end up bringing that down because that's on the outside of that absolute value world. Remember, anything outside of that world will stay outside of the world. You'll just bring it down. Anything inside of the world will end up becoming positive, okay? And lastly, letter D, okay? This time my negative's inside those absolute value brackets, so therefore, I will be changing that into a positive. So I have a +11, okay? Now looking at it more of as an expression, algebraic way, okay? We're gonna just rewrite all of this and then simplify. So if I look at letter A, I have 4, the absolute value of 4 minus the absolute value of 12. Let's look at our absolute value brackets first. Let's just change that, okay? Looking inside of the worlds of these brackets, I have a 4. It's already a positive, so I'm gonna keep it as a +4. Looking at the 12 now, the absolute value of 12, since it's already a positive, once again, it'll already stay as a positive. Now, what's outside of these brackets, once again, we bring down, which is the minus. So from here, all I have to do is just 4 minus 12. So when I plug that into my calculator, or you guys do this mentally, 4 minus 12 does give you -8. Same thing with the next one, okay? I have a absolute value of 3. So I have a negative and the absolute value of 3, okay? The negative is on the outside of my absolute value bracket, so I do not mess around with it. It's just gonna come down. Then I have the absolute value of 3. That 3 is already a positive. So all I do is just bring that 3 down. I don't make it into anything else. It's already a positive. I also go ahead and bring down that minus, and now I have the absolute value of 5. The 5 is once again still a positive, so all I'm doing is just bringing a 5 down. Okay. From here, I have -3 minus 5. If you need more of a visual, remember, if you have subtraction, you're dealing with those negatives, you can always keep, change, change. So I keep the -3. I change the minus into a plus, and I change that 5 into a -5. So basically, you're adding your numbers and keeping the sign. So 5 plus 3 is going to give you a 8, but because they do have the same signs, you keep the negative. Okay. Letter C, I have -15. So I keep the -15. That has nothing to do with the absolute value, so it does stick to a -15. Then I have a minus outside of that absolute value, and now I have an absolute value of 7. So what I'm going to do here is I'm just bringing down a 7 and plugging this into your calculator. You will have -15 minus 7, and that'll give you a -22. Once again, if you do want to do that keep, change, change, what you would technically have is -15 plus that -7. All right, now looking inside of my expression on letter D. If I look at my expression inside letter D, what we want to do, we're kind of thinking of this like parentheses, okay? So when I look at this, I want to make sure that I look at this inside first, simplify what's inside of our world, and then take the absolute value of this. So inside of my absolute value brackets, what I have is -10 plus 7. Because I have that -10 plus 7, what I'm gonna do is I'm actually gonna simplify what's inside there, and then we're gonna take the absolute value. So when I think about -10 plus 7, that does give me a -3. But once again, we have not taken the absolute value of that. So we're gonna go ahead and we're going to take the absolute value of that now. So the absolute value of -3, remember that makes everything positive. I now have a +3. Cool. Now, letter E, it's a little bit different because my expression and my operations are on the outside of the absolute value brackets. So this one's a little bit different, okay? It's almost like letter B. That 19, I can bring down that 19 because that's what's inside the absolute value, and that is a positive, so I keep it as a positive. But on the outside of that absolute value, I have a negative, so I have the -19 now. Okay. That minus is also outside of those brackets, so I'm going to go ahead and bring down minus. Okay. Now, if I look at that 13, the -13 inside the absolute value, that is a negative, so I would have to take the positive formatting of that, the opposite. So the absolute value of -13 is a +13. Okay. Once again, if we're not liking how the negative and the minus kind of looks like, how it looks like right now, we can do the keep, change, and change. So I have -19 plus that -13, and that gives me -32. Okay, and the last question on the simplifying expressions, I have the absolute value of 29 minus negative absolute value of 18. So when I look at this expression, those parentheses are just kind of there to let you know that, hey, this minus and this negative are separate from each other. So what we're going to do is we're going to just rewrite this problem, okay? Looking at the absolute value of 29 first, I'm going to do that. Since it is a positive 29, it just stays as a positive. Next, after that, I have a minus, so I bring down my minus. Okay. Now, the negative inside the parentheses. Okay. Yes, there is a negative outside the or inside the parentheses. There's nothing that we're going to do with that. All we're simply doing with that is just bringing it down because it's not part of that 18 just yet. Okay. That 18 is inside of our absolute value brackets. That means that we're not going to include that negative. So I'm going to go ahead and bring down that 18 now. Okay. All right, now this is why they did that. I have a minus and I have a negative. They're trying to let you know that, hey, these are separated from each other. So now that I can see that, remember, if you have a minus and a negative right next to each other, it actually becomes a positive. What I like to do here is I like to connect my two minuses and then make a big plus sign. So now what I have is a 29 plus 18, and that gives me a 47 because a negative and a negative make a positive. Okay. All right. And the last two examples. So what we want to do here for making fractions equivalent to a decimal or just converting them. When I have a decimal here, we know that when we look at these decimal placements, it goes by tens. Okay, so it goes tenths place, hundredths place, thousands place, and so on. So what we're doing here is we're looking at what specific place value it is and putting it over that specific 10 or 100 or 1,000. So if I look at letter A, what I have here is I'm going to make that into a whole number. So I have a zero point 0.4. So I'm going to make that into a 4 over, and I'm going to put it over the place value. This is the tenths place, so this is going to be over 10. Now I can simplify this. So when I simplify 4/10, that actually gives me 2/5. If you are confused on how I just simplified it, if I look for a common factor here, a common factor that they both have is 2, greatest common factor. So I divide both by 2. 4 divided by 2 gives you 2. 10 divided by 2 gives you 5. Okay. Now, when you do have a whole number, think about when you have mixed numbers. When you have mixed numbers, you have your fraction and then you have that whole number on the outside. This is the exact same situation. You have a decimal placement, but you also have a whole number to the left of it. When you have a whole number to the left of it, that's actually going to be your whole number to your mixed number. Okay, so I have my whole number. There we go. Okay, now we're going to go ahead and write our actual fraction. So here we're looking at what's after the decimal and make it into a whole number. So I have the 35 and I put it over the decimal placement. If I look, the tens place is where the 3 is at, and the 5 is where the hundredths place at. Because that's where it ends, I have to make sure that my decimal is over 100. Okay. Then looking at the next one, and we can actually, sorry, going back to the other one, we can actually go ahead and simplify that. So if we wanted to, you can leave it as 1 over 7/20. Please remember that your calculators can do this for you, so make sure you're using your calculators if needed. All right, letter C. If I look at this, no whole number, so I can go ahead and move on with just my decimal placement. There are two decimal placements here, so that means the tenths and the hundredths. So I'm always going to put it to the highest one, which is over 100. I'm going to make that decimal placement into a whole number now, which would be 67. And lastly, I have negative 2.45. Once again, we're going to take out that whole number. We're going to make that its own thing. So I have the negative 2. And then the decimal placement, it's 45. So that is the hundredths place. So I make it 45 over 100 because of that hundredths place. You can simplify that 40 or the 45 over 100 to negative 2 over 20. Okay. Now, looking at the decimals, now we're going to go ahead and convert decimals to fractions. Basically, what we're doing here is we're doing the exact same thing, looking at the decimal placement of it. And this is really the repeating decimals, okay? Repeating decimals are a little bit different because we don't know when it actually ends. So I can't say, hey, this is just a tenth place. Although letter A looks like it's just a tenth place, that's not true because it has that repeating sign. So that means it just repeats forever and ever and ever. So depending how many numbers you have to the right to the decimal, that's however many nines you're going to put it over. So if I look at the first one, I only have one number after the decimal. So that means I'm only going to put this over 1 9. Then I'm going to take that decimal placement that I have, which is that 5, and make that my numerator. Okay, so looking at example B, I now have two numbers after my decimal. So that means I'm going to put this over 2 9s. And once again, make that 33 into a whole number. I can simplify that, which is I can simplify it by 33. So I would put this over 1 and 1/3. Okay. All right, for letter C, we do have a whole number before the decimal. We're going to treat it the exact same way we did above. So because it does complete a whole, I can go ahead and just put a 1 as a whole number, but I'm still going to go ahead and treat the fraction like we did with the other two. If I look at my decimal here, I have two numbers after the decimal. That means that I'm going to put 1, 2, 9s for my fraction, for my denominator, okay? Then the number after the decimal will go to the top, which is 15. I can simplify 15 over 99 by 3. So my answer here could be 1 and 5 over 33. And lastly, letter D. Once again, I do have that whole number outside, so I'm going to put -1. But then I also have 3 numbers after the decimal now. So I'm going to put 1, 2, and 3 nines. Okay. Now that 234 after the decimal, I am going to put that as my numerator. And there's your fraction. Now once again, we can simplify this. So we're going to go ahead and simplify this by 3. So I get -1 over 7, or sorry, 26 over 101. Okay. We could actually simplify that by 9. Okay. All right. So that is your rational and irrational day 1.